Hello friends, welcome once again to a session on engineering graphics with me Yash Chawla from Parabola Institute of Engineering and Technology. Last time we started engineering curves and we discussed conics as well as different types of curves that are there in engineering graphics, and we also discussed construction of ellipse by different available methods. Today we are going to discuss what are different methods available for construction of parabola and hyperbola. So let's see, what are we going to discuss today? Different construction methods for parabola as well as hyperbola. This picture I showed last time also. So this time we are going to discuss construction of something of this sort, which is known as a parabola, and this which is known as an hyperbola. First we are going to discuss construction of parabola. I want to repeat this thing for if students are watching this for the first time, to make them clear that how a parabola is formed. This is basically a topic of conics. Now, why is a parabola part of conic? Now this is a cone, as you can see here. This is the cone, and here a 3D image has been shown in which this yellow part is the cone. Now if I pass a plane which is perpendicular to the edges of the cone, as you can see right here, this is the plane and this is the edge of the cone, the slant edge of the cone, and both are parallel to each other. If I pass this plane and then remove this particular section, then the shape that I derive is a parabola, as you can see here, and its eccentricity is equal to 1. Now for those who are wondering what is eccentricity, that eccentricity is defined as the ratio of the distance of a point on the curve from focus divided by the distance of the same point from the directrix. Now as you can see, for a circle, it has for this red curve, this which is an ellipse, it has been denoted by point M. Now this green curve is the parabola that we are going to discuss about. So let us take a single point M, let us say extend it up till here, and then measure the distance of MF and then M dash. So the distance that comes will be equal. So this is known as a directrix, and the point on the curve will be equal distance from the focus as well as from the directrix. For a parabola, this distance from the this point of focus and this directrix will be equal to 1. Say if the distance is 2 mm from the focus, then the same distance will be there from the directrix as well. So E is equal to 1. What are the different methods that are available for construction of parabola? There are 4 methods available for us: rectangle method, parallelogram method. These two are very similar to each other. Then there is a tangent method, and finally directrix and focus method. So first we are going to discuss the rectangle method. Now in a rectangle method, what do we have? What is the data given to us, and how do we have to draw? So just imagine if I'm standing on the bank of a river and I throw a stone. So the point from where I project the stone is the projection point, or say the launch point, and then the stone attains maximum height. Say if I'm throwing the stone from here like this, and then it goes on, it attains maximum height, and then again it descends and then finally lands. So the point from where the launch is there, the construction of parabola, that the path of the projectile is the parabola curve, and the top that is achieved, that is the maximum height. From there the descent occurs, and finally I have the point where my stone lands. So which is depicted in this figure. As you can see, I have drawn a rectangle. Now I have named it PQRS. This is just for illustration. So this is my point of launch and this is my point of landing. So the object or the stone starts from here, traces this path and lands here. This is the maximum height that has been attained. This is the total distance covered, and the path that has been covered will be known as a parabola. For this, now let us start the construction. Let us start step-by-step construction of the parabola. Now first we will draw a rectangle PQRS. Now what will be the dimensions? The width will be equal to the distance covered. That is, the width will be equal to the distance covered from the point of launch to the point of landing. The height will be the height, that is the height of the rectangle would be the maximum height that has been attained by the projectile that we saw in the previous figure. So let's see. So this is the rectangle that I have drawn, P, Q, R and S. This is the maximum distance covered, and this is the maximum height attained by the projectile, or say any object that has been projected in this particular path. Then next we will mark the point of maximum height, which in this we are considering to be the midpoint. If it is not the midpoint, then in the question it will be mentioned that this will be from this particular point of launch at, say, if I am SD, if you can see in the figure, P and Q. P and Q is the total distance covered. So in the question, if I don't have the maximum point as a midpoint, as it is denoted by C, then I'll say in the question key it is away from P, say 20 meters, and the total distance is, say, 60 meters. So it will come somewhere around here. But here we are assuming that it is a midpoint of the maximum distance covered where the maximum height is attained. The next step, we are going to divide PS, QR, SD and DR into 7 equal parts. Why is that? That we will see in the next figure. First we will divide them. First we are dividing SD, as you can see here. S and D is divided into 7 parts, 1, 2, 3, 4, 5, 6 and 7. Then we are dividing DR into 7 equal parts, 1, 2, 3, 4, 5, 6, 7. Then PS is being divided into 7 parts. Now this process, I have used dots, or you can say points, to make you illustrate that how it is being divided. In the figure where you draw it on the sheet, arcs are more preferred to be, they are more accurate. That's why here, if I would have shown arcs, then it wouldn't have been visible. That's why I have used dots. So keep that in mind, please. Moving on. Now we will from the point C, that is the maximum height that has been attained, we will connect these points 1, 2, 3, 4, 5, 6 and 7 on both the sides on the vertical segment. Thereafter, from the segment that is a horizontal base segment, we will draw straight line upwards, that are vertical lines which are perpendicular to the base, to meet these lines. Let's see how it goes. First we are drawing these lines. As you can see, C is connected to 1, then C is connected to 2, thereafter C is connected to 3, 4, 5, 6 and 7. Now I've done it for the left hand part. Now I'll do it for the right hand part. As you can see, C is again connected to 1, 2, 3, 4, 5, 6 and 7. Now what will I do? This point C1, see, this is the line C to 1. Now this line will be intersected by a vertical line that will grow from 1. Then again on this side the same thing, from 1 it will go on up till here. Then it will go from 2 up till the line C2 on both the sides. Let's see, this is P1, then P-1, then I have P2 and P-2. Now I have P3, P-3. The same process will be followed up till P7. It will go on and on and on. I have got P7, P-7. Now as you can see, this point is S itself, that is a point of launch, because the vertical line will be a point which will be on S itself. That's why this P7 and P-7 are on the vertex of the rectangle, from where this is the point of launch and this is the point of landing, for more understanding. Now what we are going to do next, we are going to draw a smooth curve that goes through all these points in proper sequence and finishes up till here. That will be our required parabola. That's what we are going to do from P7 to P6, P5, P4, P3, P2, P1, then point C. That is the maximum height that will be attained by the object. Then we'll go to P-1, P-2, P-3 up till P-7, and we will have the required parabola. So this was the rectangular method that we discussed. Now the next method that we are going to discuss is the parallelogram method. Now it is very similar to what a rectangle method is. Now in rectangle method, it was a proper rectangle. Instead of rectangle, if I use a rhombus, or say not a rhombus, a parallelogram, in which both the sides are parallel but they are not at 90 degrees with each other, that is the difference between a parallelogram and a rectangle. So if I use a parallelogram instead of rectangle and follow the same steps, 1, 2, 3, 4, the steps that I used in construction of a parabola by rectangle method, I will have the parallelogram method for construction of parabola. So let's see. Here again we will draw a parallelogram PQRS. Now the base angle must be making an angle theta with it. That is because we are moving it upwards. As you can see up there, this is the base that I have taken. Now I will draw a parallelogram P, Q, R and S. Now this SR is making an angle theta with the horizontal. So we have this parallelogram P, Q, R and S. Now we have to construct a parabola which is inside this particular parallelogram, and for this, if I am throwing an object in this particular manner, then my S would be my launch point and my R would be my landing point. That is, that point R is at some distance from the ground. Moving on, I'll mark the maximum point of maximum height. Here again I have taken it as midpoints C and D, and I've drawn this line CD. Now again the same thing I'll do. I'll divide these PS, QR, S and D into 6 equal parts. As I did there, I divided that into 7 equal parts. Here I am dividing it into 6 equal parts to make this the thing more clear to you, that it can be divided into as many parts as you want, but the more parts that you divide in, the more points you will have, the more intersection points you have, the more accurate will be the parabola. So as you can see here, PS has been divided into 6 equal parts, then QR has been divided into 6 equal parts, thereafter SD is divided into 6 equal parts, and finally DR is divided into 6 equal parts. So we have the this parallelogram P, Q, R and S. Then we took the maximum height, then we divided each of the side, leaving the top side, PS into 6 equal parts, SD into 6 equal parts, DR into 6 equal parts, and QR into 6 equal parts. Next, what I'm going to do, the same thing that I did from the point of maximum height, I'm going to join both sides, that is 1, and on the right hand side it is 1 dash, then 2, 2 dash, 3, 3 dash, 4, 4 dash. Thereafter what I'll do is, from the base segment, that is the base of the parallelogram, the bottom side, I'll draw vertical lines that are parallel to the vertical segments of the parallelogram and make them intersect the particular line. Say from 1 it will intersect as C1, and from 1 dash it will intersect on C1 dash. Let us see. Again these lines are drawn: C, C1, C2, C3, C4, C5, C6, C7, and on the right hand side C1 dash, C2 dash, C3 dash, C4 dash, C5 dash, and finally C2R. Now these are the points. Now this is C1 again, so I'm going to join 1 by a vertical line to C1 and mark the intersection point as P1. Let's see, this is my P1. On the right hand side if I do it, it is P1 dash. On the left hand side again P2 dash, P2, P2 dash, P3, P3 dash, P4, P4 dash, P5, P5 dash, and finally P6 and P6 dash. Again, as you can see that this particular point S will be P6 and this will be P6, P-6, because this C to R is a straight line, but the vertical line would be this point itself. So the intersection point will be P-6, and on this side it will be P6 itself. Now what we are going to do, again we will draw a smooth curve passing through this line. The sequence would be, first we'll go to P6, then P5, then P4, then P3, then P2, then P1, then C, then P1 dash, P2 dash, P3 dash, P4 dash, and please remember that it has to be a smooth curve so that it becomes a parabola, as you can see. So this is our required parabola. So you can find that all the steps between the rectangle method and the parallelogram method are almost same. Only the step that differs is that instead of the figure being a rectangle, it is a parallelogram, and the base angle, instead of being parallel to the horizontal, it is making up some angle with it. And we will be solving example next Sunday, so at that time you will know what is the application of using this method when we are solving examples. The next method is tangent method. Now as the name suggests, first of all we are going to construct tangents. The base height will be having, the excess height will be having. Now using that we will have to draw various tangents to a curve, that is, this in this case it is a parabola. Now for that parabola, if we construct a lot of tangents on say both the sides of the axis, and then we pass a curve that is passing through all the tangents, that is touching each and every line of the tangent. As you know, the definition of a tangent is what? A line which is touching a curve at a single point. Now if I have 10 tangents, 5 on left hand side of the axis and 5 on right hand side of the axis, and so I am having 5 points. Say this is my parabola, and I'm having 5 tangents this side and 5 tangents this side. So what will happen? I will have basically 5 points. Now if I pass a curve through those 5 points touching all those tangents, then I'll have my required parabola. That's what is mentioned here. So first step, what we are going to do is, here we are going to draw a triangle. Why a triangle? Because in a triangle we are able to have a central axis, and thereafter the lines are crisscrossed, and so we can have the final shape as a parabola that is on the bottom side. The base would be the total height, the total base that will be given will be the width, or say if I take the example of the stone again, the point of launch and the point of landing would be the total distance covered. That will be the base of the triangle that I am drawing, PQR, and its height, the height of the triangle would be twice of the axis height that is given. Axis height is what? The maximum height that is attained by that particular object if I am throwing it upwards in a parabolic motion. So I'll take the height of the the height of the triangle as twice the height of the maximum height attained by the object when it is in a parabolic motion. Let's see. Say this is a triangle PQR, and we have this is the axis PO, and this is the maximum distance that has been covered by a object which is going in a parabolic path. Point Q is the point of launch, and from this it will go somewhere like this, and then it will attain maximum height here, and then it will land on R. So this is the parabolic path that we have to trace. Now this this total height PO is twice of the axis height, that is twice of the maximum height attained by the object when it is tracing the parabolic path in this particular triangle. So I can say that the maximum height would be somewhere around here by looking at the figure, by dividing